Welcome, everybody. We are now recording the session. We are also, we have provided access to the Wordly AI bot to provide French translation. For those who were not here when I posted it previously, I will post the link again because you wouldn't have seen it if you weren't in the meeting when I was posting it. So if anybody wants to use the Wordly app to see that French transcription, please do so, or the English transcription, sorry, French translation. So I'm just, before we start, I'm Cynthia Holt. I'm the Executive Director for the Council of Atlantic Academic Libraries. I'd like to welcome you all here today to our a CAAL webinar from the Digital Preservation and Stewardship Committee. Just a few housekeeping things. We are recording, as you may have noticed. We also ask that you keep your cameras off if you're not presenting or not speaking, and you keep your mics muted so that we optimize the experience for everybody in the session. There will be Q&A time where you can ask questions, and just at that time, if you're going to, if you want to speak, please, you're welcome to turn on your camera and your mic at that time, or you can post your questions in the chat. And at this time, I'd like to acknowledge that CAAL-CBPA members sit on unceded and traditional territories of the Mi'kmaq, the Beothuk, Innu, Inuit, and Wolastoqiyik, and Pescamotmukudi peoples. Treaties of peace and friendship were first signed in 1725 between the British Crown and the Mi'kmaq and Wolastoqiyik peoples. The treaties did not deal with surrender of lands and resources, but recognized Mi'kmaq and Wolastoqiyik title and established the rules for what was to be an ongoing relationship between nations. We acknowledge with respect the diverse histories and cultures of the first peoples of this region, and we express our gratitude as guests on this land. At this time, I would like to turn the session over to David Mawini, who is the University Archivist at Mount Allison University. He will be our moderator for today. David.
Thank you, Cynthia. So today, the title of the webinar that we're conducting today on behalf of the Digital Preservation Steering Committee is Improving Access to Digitized Handwritten Material through AI, and it's a pilot project with Transkribus software. This presentation will cover the origins of the Canadian Research Knowledge Network's project with Transkribus and how they plan for and launch the pilot project in collaboration with the Library and Archives Canada and where the project stands today. We'll also learn more about how Transkribus platform is being used in the Nouvelle France Numérique, or the New France project. And today's speakers are Francesca Brzezicki, the Heritage Engagement Officer at CRKN, and Maxime Gohier, Professor of History at the Université Québec at Rimouski. Francesca holds an MA in Public History from Carleton University, and she joined CRKN in 2019 and has a background in research and outreach for digital heritage projects. Maxime Gohier, as I said, is a professor at Université Québec at Rimouski, and since 2019, he has been a co-director of the partnership project Nouvelle France Numérique, which is using the Transkribus platform to transcribe all of New France's archives. So I welcome you, and I'll turn it over to both of you for the presentation. Thank you.
Thanks, David. I'll just share my screen with the presentation. That seems to be working. So I'll just say thanks everyone for being here for this presentation. Me and Maxime are excited to talk about this project with you. And just making sure I can advance the slides. Always a good thing. Okay. So just we thought we'd start with a little bit about how we are involved with this project. So as for myself, as David mentioned, I am Heritage Engagement Officer at CRKN. I actually assumed that role kind of midway through this project. So while I'm involved in communicating and presenting on the project, I've been less so involved with the actual work, but I've learned certainly a lot about it through doing presentations like this. And I'll hand it over to Maxime.
Sorry, I had a problem with my microphone. Yeah, so as David said, I'm a history professor at UQAV, and I'm specialized in Aboriginal history. So this is one of the points why I was involved in the pilot project with CRKN. I'm also a Transkribus user since at least 2018. So I have quite a good background with this technology, and probably one of the first, maybe not the first, but one of the first in Canada to use Transkribus and to work with this HDR technology, ICR HDR technology. And so this is why I was involved in producing training data for the project of the CRKN.
Okay, so some background on the project. Many of you are probably familiar with CRKN, but I will go through this slide anyway. So we are a consortium of now 89 university libraries and research institutions across Canada. I think our newest associate member is Library of Parliament, which has brought us up to that 89 number, which is exciting. And in 2018, CRKN and the former Canadiana.org merged, and as a combined organization, we manage the Canadiana collections, which are Canadiana.ca and Heritage.Canadiana.ca. And it's the Heritage collection, which we will be discussing today. All right, Heritage is a joint project supported by CRKN members and Library and Archives Canada. It was launched in 2013, and it includes a wide range of digitized archival microfilm from LAC, totaling approximately 42 million pages across over 900 collections. Although I think that number is probably a little bit out of date at this point. I think we might be closer to 43 million now. It's a really huge collection. And the majority of it is handwritten. So we estimate about 60% of the microfilm there is of handwritten content. So that has posed some discovery challenges for this collection. As I mentioned, there's a really vast amount of material, and for that material, there is limited finding aids and indexes. And when they do exist, it's not always very easy to find them or to interact with them. There's also limited metadata and search capabilities on the website, on the Heritage website. That's a little bit more of a function of the current functionality of the website, but it has been an issue. And then because there is so much handwriting, it means that we haven't been able to process that material with our traditional optical character recognition software. So that means that there has been no full text search for the handwritten content in Heritage. And because, as I said, it's 43 million pages, that means it's a challenge to search in that collection. However, we did start to see the beginnings of a solution to this problem when we connected with Maxime here. I believe it was his presentation at the 2020 CRKN conference where we first realized that Transkribus, that intelligent character recognition existed and could maybe work for us. So that's how we were first introduced to it. And we held an initial meeting with Reed Co-op in June 2022. Although I will pause and just say that we did research other ICR software options before settling with Transkribus. but I think Maxime will go into a little bit more detail on that. Another important part of developing the beginnings of this pilot project was what material were we going to select, because it wouldn't be realistic to process the entire heritage collection with ICR. So we chose a section to start with, and in collaboration with LAC, we chose the RG10 font subsection, records relating to Indian affairs. And this was selected because it's a highly accessed font. There's a large amount of handwritten content, and because it relates to the history of Indigenous peoples, and it's frequently used by researchers researching Indigenous history and Indigenous claims, it was important for us to give priority to this material. And the initial batch was a large collection called the Departmental Letter Books within the records relating to Indian affairs. And this was selected as the first batch of material because the handwriting was consistent. There's a wide variety of topics. It would meet research needs. It was poorly described, and the time period of the records meant that there's a lower risk for sensitive content with this material. So at a glance, we launched the pilot project in March 2023. As I mentioned, it is a partnership with Library and Archives Canada, and the full scope of the project is about 2 million images. I believe it's actually a little bit over that, but that's the full scope of the pilot. The initial batch was about 600,000. The second batch was about 500,000, and then we left a third batch of about 1 million images to be identified. And I'll talk a little bit more at the end of the presentation about where we're at with those 3 batches of content. But I believe now it is over to Maxime.
Thanks a lot, Francesca. So, yeah, thank you very much. Okay. So I'm going to talk just a little bit about the difference between OCR and ICR, just to make sure that everybody is familiar with these different technology, because OCR has been in the landscape of digitizing archives since a long time, but ICR is more recent. So OCR was developed as early as the 1950s, but was only made popular and available for personal computers in the 1990s. The first commercial software for OCR was developed by Ray Kurzweil in 1974, which was sold to Xerox in 1980 to become maybe something that a few around know is OmniPage from Scansoft. Other major OCR software were Hewlett-Packard Tesseract and ABI Fine Reader, which is actually probably the most used software for OCR, and the one that CRKN uses for its Canadian collection. So both of these Tesseract from Hewlett-Packard and a Fine Reader from ABI were developed in the 1980s and 90s. And this is when it became more used in the heritage milieu. So to convert printed documents into machine-readable text, OCR software use a matrix matching process. This means that OCR systems tries to match the graphic characters or the glyphs that they identify in an image with a set of characters stored in a library. In the 1980s and 90s, as computers became more powerful, libraries were expanded to recognize large amounts of fonts in various writing systems, which has helped to improve performance on older imprints. Dictionaries were also added to improve recognition of existing words rather than random character strings. However, matrix matching can only recognize characters that are actually included in the original dataset of the software, making these systems suitable only for printed text and unable to recognize handwritten characters, the variety of which is virtually unlimited. The Canadiana project, formerly called Early Canadiana Online, was launched in 1997 with the digitization and, I will say, OCRization of the collection of Canadiana, the Canadiana Institute for Historical Micro Reproduction. Today, Canadiana collection counts approximately 96,000 titles with more than 19 million OCR pages. In comparison, the Google Books project was launched only in 2003. Today, OCR software like ABI Fine Reader achieves error rate between 1 and 5% on heritage document, and this is what our CRKN can have on the Canadiana collection. Intelligent character recognition, or ICR, you can switch slide. Also often referred to as handwritten text recognition, so maybe some of you know better HTR. It's the same as ICR. So it has emerged in the last decade. Unlike OCR, ICR uses artificial intelligence, or AI, to train recognition models adapted to different handwriting styles and languages. Thanks to neural networks and deep learning, AI algorithms can learn to identify the distinctive features that will enable the recognition of characters within a range of scripts. This requires giving the machine a very large amount of training data, which consists of segmented text lines in an image, together with their transcription into digital characters. The algorithms essentially use convolutional neural networks to learn how to predict as accurately as possible the probabilities that the identified graphic signs correspond to specific numerical characters, or digital characters. So ICR's technology was essentially developed from a main project carried on between 2013 and 2016, which is the project Transcriptorium, carried out by the University of Valencia, thanks to a grant from European Union. This project then gave rise to Transkribus in 2016 at the University of Innsbruck, which made accessible to the public as web interface, no, not a web interface, PC, personal computer interface for producing training data. So, and it's essentially associating text lines in images with their transcriptions, and the AI tools for training recognition models. Since 2019, another system has been developed from Transkriptorium. It is the eScriptorium software piloted by the INRIA Institute and Paris PSL University in Paris. Other systems have also sprung up since then, some free, but many, the more performant, usually proprietary. So we can talk about Teclia, Quartex, Google Document AI, Amazon AWS Extract, and so on. Generally, except Transkribus, right now, most of these systems are not as efficient as we could hope. As users produced training data, AI tools were refined. In particular, the segmentation tools used to identify lines of text on pages became much more effective. Natural language processing tools based on recurrent neural networks and n-grams algorithms were also added to enhance the prediction of logical word sequences. Adding model language to an ICR recognition model can easily increase its performance by, let's say, 5 to 10%. So what's more, ICR tools make it possible to use existing model to pre-calibrate the parameters of a model, greatly speeding up the training process and considerably enhancing the performance of the generated model. Transkribus, for example, offers several supermodels. You can switch the slide, please. Oh, yeah, this is just to show you how alignment of training data is processed by the interface. So you have the transcription, which is segmented in the image, and the text image is segmented, and you have the transcription on the other side, which correspond line by line. You can switch to the other slide also. Yeah, so here we are. sorry. Transkribus, yeah, for example, offers several supermodels in different languages, comprising hundreds of thousands or even sometimes millions of words in the training data. That can be used not only to transcribe document, but also to train more refined or, let's say, fine-tuned models. Similarly, the HDR United website provides free access to training data produced by users from all over the world, which can be used as a basis for training models suited to specific needs. HDR United is mostly devoted to make the switch between Transkribus and eScriptorium more easily. Using all these technologies together, it is now quite easy with less than 100 pages of ground-truth transcription to train ICR models able to transcribe virtually any handwriting with a character error rate, or CER. I will talk a lot about CER in the next minutes. CER below 10%, which means that less than 10% of characters are erroneously recognized. For corpora with relatively homogeneous handwriting, such as, let's say, notarial records, models can easily achieve CER of 4 or 5%, and sometimes even less, depending on the quality of images, as well as the scripts that have to be read. ICR technologies are currently undergoing rapid development. In the last 2 years or so, new algorithms based on transformer neural networks, so I talked about convolutional neural networks, which are used generally in PyLAIA technology that is used by Transkribus for the segmentation of text and the recognition of characters. I talked about recurrent neural networks also that is used to add text recognition, so text formation. And so now the new technology is using transformer neural networks, which is another type of neurons. And they have resulted in the introduction of highly versatile supermodels with significantly improved performance. You can see here on this slide different transformer model. So just the one before, sorry. Yeah, so on the right side of the slide, you can see transformer models as well as also as PyLAIA models. So the English Eagle, let's say, is a PyLAIA model, while the German Giant or the Duchess Eye is our transformer models, which are a lot more efficient. So in 2023, Transkribus, for instance, launched a model called the Text Titan, of which I will talk more in detail later. This model was trained on a data set of more than 5 million text lines, which means over 20 million words, supporting 6 different languages and achieving an average CER of 2.95% on its validation data. So transformer algorithms, however, demand very large computational resources, making it impossible for a normal user to train their own models or even fine-tune existing one. It's too consuming. The main challenge that developers of open ICR platforms are currently tackling with is the integration of large language models, LLMs, into text recognition algorithms. These LLMs will further enhance model performance as well as facilitating automated named entity recognition, NER. You can show the other slide, which show you how easy it is to choose a model and recognize a page. So I show you an example from the corpora that we transcribed for the pilot project. I'm just going to talk a little bit about Nouvelle France Numérique, a few words, because this is where I came from in the project. So it was launched in 2018 with a team of colleagues, historians and anthropologists, researchers and literatures interested in New France. So now it is co-directed by myself and Léon Robichaud from Sherbrooke University. The aim of Nouvelle France Numérique, or Digital New France, is to transcribe, as David said, all of New France archives, which is probably around 5 to 10 million pages. But to do so, we understood that we need to develop a culture of collaboration in transcription of text and in the use of AI technology. Up to now, we have probably transcribed around 300 or 400,000 pages of documents. And we are also trying to develop technologies to help the researchers to produce their data, to share their data, and to make it available for AI treatment. So when CRKN initially decided to launch its pilot project in 2022, an overview, as Francesca said, of ICR systems was carried out, and several options were tested to assess their accuracy, ease of use, and cost. Amongst these were Google Cloud Vision API, Teclia Ocelus, and Amazon TextTract. The result of this scanning were definitely favorable to Transkribus. Initial tests indeed revealed CERs of 1 to 2% for typewritten materials and 5 to 7% for handwritten materials. Thus, an agreement was signed with Read Co-op, which was to complete the ICR processing of the whole RG10 manuscript sample. I think you can step to the next. And the other one. Good. Also, the other one. Among the factors that drove the choice for Transkribus was, of course, the very encouraging results of the initial test, but also the organization's cooperative business model. Since 2019, Transkribus is supported by a European cooperative called Read Co-op, which has more than 200 members worldwide, mostly archive centers, libraries, museums, and universities or research centers. The co-op is genuinely committed to making historical documents more accessible, as underlined by its slogan, Unlocking the Past. All profits are reinvested in technological development to the direct benefit of its members, as well as the users community. Transkribus currently attracts over 300,000 users worldwide and offers a wide range of services. Beyond Transkribus, Read Co-op also offers a series of solutions for making historical sources more accessible with digitization tool. There's a scan tent that can be used that they produce, a free user-friendly web interface, as well as the web-based solution for publishing and searching archival collections. For the more specific needs of CRKN, Read Co-op also offers an API platform, which is named Metagrapho, specially suited to the processing of very large batch of documents by limiting storage requirements and therefore usage cost. So this is where I was involved. As a specialist in Aboriginal history, I'm particularly familiar with the RG10 records and especially with the clerks who wrote the letterbooks of the department, which were chosen for the project. I'm also fairly familiar with the staff of the department at the time and with the terminology of specific to these documents. Ethnonyms, names of reserve, specific abbreviations, subject covered in correspondence. I was therefore able to help produce ground truth data to ascertain the possibility of producing a model more reliable than the state-of-the-art transformer-based text item that I talked about earlier. Great. I've also involved a team of volunteer paleographers called Les Gardenautes, or the Gardenautes, with whom I'm pursuing a citizen science project in the frame of Nouvelle France Numérique, and who have solid expertise in producing training data for ICR. Together, we ended up transcribing over 800 randomly selected pages from the entire collection of letter books, while carefully monitoring the representation of the different writing hands present in the corpora. To help decipher more complex words, place, person, and community names, we relied on research tools produced by Indian Affairs. Particular attention was paid to the accuracy of the image segmentation to ensure that all information was read correctly by the system. There's foliation, volume numbers, dates, signatures, etc. Finally, some very poor quality pages were eliminated from the ground truth sample to avoid corrupting the model. Although most of Heritage's images are of very good quality, despite being scanned from microfilms, some are totally illegible, both to human eye and ICR tools. In the end, the results were very conclusive. Comparative tests on some 50 randomly selected pages showed that the model we generated with 750 transcribed pages managed to outperform the TextTitan model. Our model has achieved an average CER of 7.21% on its validation data. Although Transkribus suggests a CER of 2.95% for the TextTitan, it must be understood that this number is measured on data extracted from the training set. So it corresponds to the training set. And mostly in English, the Transcribe Bentham project was the main producer of data for English. When tested on our 50 pages sample of RG10, the results are not quite as high, reaching an average of 9.03%, so not the 2.95%. However, the deviation from the mean of the results must also be taken into account when assessing a model's performance. This is because we can see that pages with particularly high error rates weight heavily on the measurement of the mean. To get a better idea of the result, it's worth noting that the model we produce achieved a result below the 5% error mark on 50% of the pages, while the TextTitan achieved this only in 25% of the cases. So, Francesca, you can go on with the rest of... tests and verification, excuse me, were conducted by CRKN staff. Research were made of archival info, fonts title, archival reference. Nominal information were also researched, personal names, place names, community names, and numerical information, years, page number, stuff like that. Thematical subjects were researched, medical, contract, word specific. Results were very encouraging for the staff, CRKN staff, and they noticed some problem. Numbers are hard to decipher for ICR tool because compared to words or sentences, which organize characters, letters in a way that is logical. Numbers are randomly organized 1750 instead of 2024. There's no logical for this organization. And also uncommon proper names. So proper names that are not particular to Indian Affairs, to the regular people involved in corresponding with Indian Affairs, the model will have more problem to recognize these words. And but CRKN staff have understand that results can be improved by using simple search tools like jokers in request. There exist otherwise other systems that can be used to go over the problem of, let's say, a 5 or 6 or 7% error rate, which is libraries developed in Solr research systems or even Elasticsearch programs. These are called the fuzzy research tools. So this can be added also for researching very easily words, even though you have 5 or 6 or 7% error rate. Yeah, so back to you, Francesca.
Hey, thanks, Maxime. Okay. There we go. Okay, so oh, I think these were, yeah, those were a few extra slides. We've had a busy couple of weeks, me and Maxime. So putting this presentation together, yeah. But in this section here, I'm going to talk more about how to use ICR transcribed material on Heritage. And it's pretty straightforward. You can enter a search term on the Heritage homepage using the search box, or you can navigate to a specific collection that has been processed with ICR, like for example, the departmental letter books, and enter your search term in the search within this collection box. You can also do searching from within a reel. So here I'm on reel C7420. And once you're in the reel, you can click on the magnifying glass icon in the image viewer and enter your search term there. And it will bring up a list of the corresponding images or the images that include that search term. You might notice that there's no search term highlighting on Heritage. We are aware it is something that we are working on fixing very soon, but we do have a bit of a workaround for that if that is important to your research, which is downloading a PDF of the file that you're working on. We have a few different PDF options. You can download the entire reel, or we have a tool that allows you to download a portion of it. And you can use that PDF to do your searching, and your PDF tool should highlight the search term for you, as you can see here. Another thing you can do, because the ICR data is embedded within the PDF file, is simply copy and paste from a PDF. So you can select the text, hit copy and paste, and put it into a document. One question that we frequently get is if we are going to offer just the plain raw transcription data. And we can't offer that right now, mostly due to just a functionality issue or challenge rather than kind of like a policy challenge. But just to say that is one thing that we are not offering right now, but in the future may be an option. User support is something else that we are focused on for ICR transcribed material. So as Maxime mentioned, our high-level search tips can really improve the search experience for this material. Yeah, things like using the joker or wildcard characters, quotation marks, that can really help. And those are all on our Navigating the Collections page. We also have a specific guide for our ICR content linked on that Navigating the Collections page. And that really includes, well, it includes some of those more specific search tips, but also some supplementary materials that we've been really fortunate to receive from the community, including a database of Department of Indian Affairs personnel developed by the University of Saskatchewan, as well as a spreadsheet and column description index for that database, which gives a lot of really important context on how to use that tool. And there's a lot of really, really good information in there. And we also have included a link to the searchable RG10 finding aid developed by the Union of British Columbia Indian Chiefs. And then lastly, the accessibility of this material is also on our minds. One question that we have received is if we are doing any human verification on the ICR transcription, and we're not, simply because it's not realistic for humans, for us to go in and verify that huge amount of transcription data. So we are considering taking steps like including a statement on the Heritage website or elsewhere stating that this material has been transcribed with AI and has not been human verified, and then including a feature on the website where if a user encounters maybe a poorly transcribed page or section of text, they can flag that to us. So we can include a button that will allow them to send a message to us easily, letting us know. So those are some ideas that we have. about how to ensure that we know if there is material that's posing accessibility issues, and that we can let the community know that this material hasn't been human verified and there may be some errors. All right, where are we now? So we were really fortunate and really glad to see a very positive response to this project. This is a testimonial we received from quite early on, but really the positive feedback has been strong with this project. And as I said, that's been really great for us to see. Currently, we're at, and these numbers are rough, but we are at about 904,000 transcribed images online, about 460,000 with Read Co-op, and about 812,000 in the process of being exported, and 0 additional images to be identified. And I think this is the first time I've given this presentation, or this is the first time I've given this presentation where that last number has been 0. We had a bit of trouble getting all the material selected for that final batch of content, and we have it all identified now. And yeah, it's exciting to be able to move forward with that 3rd batch. On this slide, I have just a few examples of other collections that have been transcribed as part of this project. These are some of the larger ones, but there are also many smaller collections that are one, 2, 3 reels that have been transcribed as well. And then where does this project fit into CRKN's larger plans, or where does the pilot project lead to? So we do have a very robust Canadiana infrastructure roadmap, which the purpose of which is to prepare Canadiana with open source, open source and modern technologies to bring it up to date in preparation for our flagship project, for which we have prepared and submitted a CFI grant application, and that is our Digital Collections of the Future project. I can put a link in the chat afterwards. You can read more about that project at the CRKN website. The page is called Future of Canadiana. But that is really going to be a transformative project for Canadiana that we hope to be able to carry out. And the improved search and discovery that ICR can give to the Canadiana collections as a whole is going to play a really big piece, not only in the basic functionality of the website, but also in preparing it for potentially transformative usage. So as I said, I think it's a really important piece that will underpin a lot of the future plans that we have for Canadiana. There is a QR code there to see the full roadmap on GitHub, so you can use that, or I can also pop a link to our GitHub page into the chat. And I don't know, Maxime, did you want to add something on that?
Yeah, maybe if people want to know just very shortly what the CFI grant is about, the project Digital Collections of the Future is to leverage on Canadiana and heritage collections to develop AI API to recognize named entity in the documents, and to transfer all these information into indexes and into repository of RDF triplets. Also, the project aims to apply a decolonized methodology of metadata on the whole collections of Canadiana, and also to deploy a IIIF repository and technology to help other archive centers and libraries to connect their collections to Canadiana collections in order to pump the development that was made, that will be made on the basis of these collections. So, yeah.
Mm-hmm. Okay, lastly, just a slide. If you're interested in learning more or joining a community in relation to this work, Scholars Portal has a community of practice for AI and machine learning in libraries on their Mattermost platform. So you can feel free to check that out if that would interest you. And also you can feel free to contact us at CRKN with any questions. I will say that our beloved senior manager of heritage services, Jason Friedman, who really steered this project, his last day at CRKN was last week. He has an exciting new job at the University of Saskatchewan. So all that to say, Jason has left, but we will do our best to get you information if you do have questions about CRKN's project. And I think, unless you have anything you want to add, Maxime, that is it for us today. So thanks so much for listening, and we'd be happy to take any questions.
Well, thank you very much. That was very, very informative. I enjoyed that presentation a great deal. I will open it to the floor if people want to either put something in the chat or potentially speak directly. One of the things I was wondering about in the PDF version that you showed in your slide deck, one of the things that I noticed was a discrepancy was the punctuation mark. So someone started the word influence. They had IN with a hyphen, and then fluence was on the bottom. And I'm wondering how the system is working with punctuation marks. I'm sure text is not it's probably fairly easy, but I'm curious to know what your thoughts are on punctuation.
Well, normally, if punctuation is in a contemporary style, let's say, ICR will deal quite easily with punctuation, with normal punctuation, let's say, because a point is a character, a comma is a character, so it will generally read it quite easily. There's specific characters that are more hard to recognize for ICR tools. When you meet dito or do for repetition, you often have quotation marks that are used, and this is more it's more difficult to recognize. But when you go to older scriptures, let's say 17th and 18th centuries, then the punctuation is more haphazardly used by scripters. So then evidently the ICR tools will have more difficulty recognizing, because there's no logical use, less logical use of punctuation, so the computer will have problem dealing with less logical usage. Yeah.
I'm also curious about situations where someone is writing in, say, English or French, and then they throw in Latin terms in the midst of that, or abbreviations. Does the system recognize them as a different language, or how does that work?
Abbreviation is very easily dealt with by ICR tools. Because if an abbreviation is considered as a word, well, it's a token, so it's taken into account by the system as a word. So you can either decide to resolve the abbreviation and train the model with resolving abbreviations, or you can decide to keep abbreviation in their abbreviated form and leave the model recognize the abbreviated form. So let's say MR for Mr., you can either choose to have it expanded or conserve the abbreviated form. There are other problems that might happen because depends. It really depends on what you want to do, because generally you prefer to keep the transcription as it is in order to have better recognition of characters, and then use an API after, or an algorithm to convert abbreviations into either type of expansion or regular forms. So there's a lot of things to think about, and it really depends on the ends that you want to achieve. So if you produce training data, you better transcribe exactly what you see, and the computer will manage to figure out this type of data. Yeah.
Okay. There are some comments in the chat. I'm curious, you said that this is a pilot for CRKN. Will you be continuing to use Transkribus for additional fall in heritage?
Yeah, we would certainly like to. Absolutely. Yeah, it's been a great pilot. As I said in the final slides there, we hope that this work can carry forward into our larger work with Canadiana. In terms of the next font which would be chosen, I'm not sure about that. I think we would probably need to have more discussions with LAC, and consult with them to see if they have content that they think would be a priority. But yeah, certainly we hope we can continue this work.
And if the CFI grant is successful and goes on, the plan is to have an on-premise implementation in Quebec of a Transkribus system, and transcribe the 40 million pages of heritage in about 2.5 or 3 years.
Wow.
So it really depends on the amount of money coming in.
Right.
Yeah, exactly.
Yeah.
Yeah. I'm also curious about the sort of the dictionary that would be used if there's spelling errors. I know that in many of the census documents you have soundex options, and I'm wondering if that has been built into the Transkribus software, because they're British and American spellings of words or variations and that sort of thing. So I'm curious to see how that's been addressed.
It also reminds me that there's a part of your last question that I haven't answered. So I'm gonna mix all this together. The point is really that it depends. It really depends on the training data that you put in your model. So your last question was also on languages, which I have not addressed. If you have Abenaki words, let's say Abenaki dictionary, French and Abenaki, well, as long as you have enough training data, the algorithm doesn't know that it's a language or another, so it will learn to figure out how the language works. So for sure, if you have very small amount of Latin quotations into English or French documents or corpora, well, the algorithm will have problem managing this input, because it's a very small amount into a very huge amount of French or English. But if you have a good quantity of training data, well, the model language will learn to on the basis of what you give it. So even if you have, let's say, because in 17th and 18th century French, we have this problem that words are written haphazardly with double letters, simple letters, agglutination also, words put together. But as long as you have enough training data, the algorithm will figure out what character it is, and then the language model that you add on the recognition algorithm will figure out what's the probability that a word written this way should happen. So it's really a question of probability calculation. So
Okay.
that's about it. It's really surprising how it can deal with not unregular spelling and unregular syntaxes also.
Well, that's very interesting.
Yeah, the one thing I'll say just to Rachel's question in the chat, we had a bit of a discussion about error rates. And there's differences, and Maxime, correct me if I'm wrong, there's differences between the error rate, the actual error rate for the entire collection versus the material that was used for validating the model. So we have numbers that we've received from Read Co-op, from Transkribus, about the error rates that we have, but in actuality, they're often lower than that. And I will say, just talking about being surprised by how well the models can work, we were really surprised at CRKN when we did that initial real testing to see how well the transcription worked. It was pretty incredible. Not to say that it's perfect, or not to say that it doesn't make mistakes. Like, there are mistakes, but yeah, the actual error rate has been, I would say, lower than 8 to 10%.
Yeah, exactly. And this is what I was trying to explain with the question of discrepancy with means, because you have an average error rate, but usually the let's say that the pages that have the worst error rate, computed error rate on their after calculation are generally quite bad because of a problem, let's say, either in the image or in having vertical text with mingling with horizontal text, or even let's say that you have problems with the margins of the page, or so it's generally these pages will weight heavily on the average error rate. So as I said, on the sample that we selected to make the calculation, generally we had 1, 2, 3, or 5% error rate in 50% of the cases. But the other 50% of the cases, there's probably the half, so another 25%, which is between 6, 7, or 8%. And then you have few pages with 60% error rate, and 20, 28, which is very bad. So these are weighting heavily on the average calculation of the error rate. So, but even with this type of average error rate, if you compare this with all the journals that have been digitized in the available collections on the web, let's say BANQ numérique, BANQ numérique with its journals, historical journals, you have a lot worse than 8 to 10%, and people are using it without noticing that that the OCR have been that bad. OCR is being worked again on several materials, like the use of a bifind reader on Canadian collection, which help increase, because 5 or 10 years ago, even Canadian collections was OCR'd with error rate of 15, 20, 25%, or even more. But we were using it and with a very high value for research. So going under 10% is quite good. Going under 6% error rate is excellent, and you can manage a 6 or 7% error rate very, very easily with fuzzy research and jokers, and you will find what you search for. So this really nuance the problem, the question of error rate. As long as it's under 10%, it's already very, very good.
The one question that I had, Maxime, was whether or not the person being left-handed or right-handed affects that rate.
Absolutely. Well, I haven't seen any difference in this.
Okay.
Yeah.
Interesting.
Really. Well, in fact, I haven't noticed any left-hand writers. Because I think people were really
well, they were forced to learn to write with the
exactly.
right hand.
They were hard treated at this time.
Yes, that's right. Yeah. No, that's interesting. Well, we've gone a little bit over, so unless anyone else has any other questions, I really like to thank both Francesca and Maxime for this very interesting and informative presentation. I really enjoyed the discussion. I thought it was very, very useful. And I may be reaching out to some of you with some follow-up questions on potential project as well. So unless someone else has something that they'd want to add, I'll thank you on behalf of all the attendees, and we appreciate your time today.
Thank you very much, and thanks everyone for joining. It was really great.
Thank you very much.